Well, good morning, everyone. First of all, I'd like to thank the Telecoms Regulatory Authority for giving me this opportunity to talk about a subject that is very dear to my heart, and that is about improving the decisioning effectiveness of large, complex organizations. So, my name is Stephen Brewis, and I recently retired from BT just a couple of years ago. BT, incidentally, is the telecoms incumbent in the UK. I retired as Chief Research Scientist in an area of organizational science. I wanted to be able to understand how we could actually maximize the value of our people within a business. So this is something that I've been working on for a good number of years now. Incidentally, it's like many sort of areas like this. Each of these areas have got a science. We have various sciences, as you'll know. We've got the physics as a science, chemistry as a science, and also cybernetics as a science. So it's the science of about regulation and control. So this is the area that I've been sort of focusing on with working with universities. Within BT, prior to retiring from BT, I was responsible for the development of decommissioning plans for the whole of the UK's System X and System I telephony network. That's the network, the digital network that we've been using for the past 30 or 40 years for making telephony calls. And that's slowly being replaced with IP. So the challenge that I've had there is to build plans that are optimized, that are going to minimize the cost to the business in the closure of that massive network. And I may be later on, I'll talk a little bit about that. My research has involved me working with some of the top universities in the world. I've been working with the Judge Business School at Cambridge University, the Mathematics Institute at Oxford University, and the Sloan Business School at MIT, Boston. Maybe just to reflect on the research I've been doing in the past, I think the key enlightening moment in terms of understanding really the power of models. Remember, the purpose of this talk isn't really for you to understand the details of what I'm talking about. I think the important thing to take away is understanding the power of models. And I'll repeat that, is to understand the power of models. I don't think that can be overemphasized because of the real value we can get by recognizing that the value that we can get by being able to look at the world in a structured way. But my sort of moment of enlightenment was when I was doing a BSc in engineering at university. And we had a project to do, which was really to try and effectively design a pneumatic vibrator. Now, remember the challenge that we were given in class. We were only, first or second year, was just to design a pneumatic vibrator that would actually work. It would be built in the lab. We would put pressure onto the vibrator and it would vibrate. Okay, so the idea was to design something that would just work. I wasn't really happy with that. So in background, what I would do is I built a mathematical model of a pneumatic vibrator, because what I wanted to do is I wanted to design the vibrator in design space, right? And make a prediction of how it's going to behave. And I was just curious about this. I wasn't expecting a lot to happen. But anyway, you know, I designed this. I gave the model different pressure parameters. I gave the model different sizes for the cylinder, a different diameter of the cylinder, different length of the cylinder. And I built an output curve that predicted that this would vibrate at that sort of frequency. And I thought, there's no way this is going to vibrate at 60 hertz. It's quite a heavy thing. And I thought maybe the maths must be wrong. But I looked at the maths and I thought, I can't see anything wrong here. Anyway, on the day when this actual real device was built in the material world, I was overwhelmed that the two curves, my prediction of the behavior of something that had never ever existed, was very close to its behavior in the real world. And that was my enlightenment moment. From that moment onwards, I was really transfixed with the power of using models. Okay. So I spent most of my time really working in industry rather than at university. I would always be working in parallel, understanding the physics and the sciences of everything I'm doing. So I got a degree in engineering. I'm a chartered engineer. I'm also an honorary fellow of the Cybernetics Society, honorary fellow of Manchester Business School, and of course I'm a visiting fellow at the Khalifa University. So I'll start off really just explaining the slide set that I've actually designed here. I'm on about the power of models. So what I've done is I just intuitively, I convert my presentation into a model. And we quite often use variety as a way of trying to understand how complex a model is, its ability of being able to absorb perturbations from the environment. And this is an example if I wanted maybe to change track as I'm going through my presentation. I don't have to go into the slides and move them around. All I've got to do is to be able to click on another icon and I can change the flow through the actual presentation. So this is an example of a model in action. So this is an outline of the talk that I'm going to be doing. But just before I get too heavily involved, let me just briefly introduce EPTIC. So who are EPTIC? So EPTIC is the Emirates ICT innovation known as EPTIC. It was established just over 10, 11 years ago in 2009 as an ICT research and innovation center. It's established by Etisalat, BT or British Telecom in the UK and Khalifa University, as well as being supported by the ICT Fund. We are located at the Abu Dhabi campus of Khalifa University with management and research staff from BT, Etisalat, the Khalifa University. So just bear with me. So EPTIC aims to provide advanced applications and services through the use of applied intelligence and intelligent ICT systems, in order to put in place the support infrastructure to facilitate the development and enable the digital networked economy in the UAE and beyond. We collaborate heavily with industry, universities, and governmental organizations in the UAE and around the world. And we believe EPTIC is a driving force for innovation in the field of applied intelligence and intelligent ITC systems. So let's have a look at models. So models are ubiquitous. We don't really realize this, but even when I'm looking outside my window and I can see cars driving down the roads, I can see different colored cars. I can feel the temperature. I can see things, and that's because what we've done is we build a mental model of whatever there is out there. We build a mental model that will help us to survive. And it's interesting, our lineage has been around for about 3.5 billion years, ever since our sort of most recent ancestor. You know, we've been around that time. We must have something that it takes to stay alive. And I'll come on to some of the work that was done by a colleague of mine in this area that I want to use when I'm talking about organizations. But models are ubiquitous, they're all around. But what is interesting is that we can't see the entire world. If we take the spectrum here, we're only seeing part of the spectrum. So effectively, we've evolved to build models of adaptation, models that enable us to survive. So we're doing this all the time. As I walk through the room, remember, I can't see the room. I'm building a model of the room in my mind's eye, and I'm walking through that model. So models are all around us. To such an extent, we don't even realize we're using them. It's like being a goldfish in a goldfish bowl. Maybe the goldfish is not aware of the water because every direction it moves in, there's water all around. There's no distinction it can make from its environment. And we have a similar problem, is that we can't easily make a distinction of our environment from models because we've always been inside a model. And I want to try and take us outside of that, and we can actually see the use of how we're using these models and the power we can be getting by using these models consciously. So I'll move on and give you a view of the world through those models and maybe what benefit I feel as if I'm getting from this. I'll go back a number of years ago. I got my first motorbike. It was a BSA Bantam 125. And being curious as I am, if anything went wrong with the motorbike, I would want to be able to repair it and fix it myself. And invariably, I would build a mental model of that. It's always the control system that fails, so I wanted to be able to build a model of the control system. So I build this mental model in my mind's eye, and what I can do is to use that mental model to go and find out what's wrong if the motorbike is not working. And it's interesting, I'm building this model, but I'm also asking questions through the model, right? I'm building a model and I'm asking questions through the model. And that's very, very important, because what it means is that if I get an answer to that question that I'm asking through the model, I'm able to make changes to the model. I'm not asking a question that is a million miles away from the model that I can't bring into that model. Otherwise, I've got two separate models, and that's no good. I've got two separate models representing the same thing in the real world. I've got to somehow bring them together. So the technique that I've developed and the technique that I'm using on an ongoing basis is to be able to use the model, to use the scaffolding within the model, to be able to ask the question. I'm asking the question through the model, and I'm absorbing the answer in that model. So you can imagine that the model is like a bit of scaffolding. And initially, it starts as a straight pole. So I'm using that to ask the question. I get the answer back, and I might bend that pole. So that pole is bent a wee bit, and then it might bend again, and then it might bend again down to infinitum. But I'm always asking the question through the model. In this case, I'm building this model as an individual in my mind's eye. So I'm going to say that the variety of the model, the complexity of the model is relatively low, right? And I would say that the operational variety is equal to the management variety. I'm managing that operation, right? So effectively, if I don't want to feel intimidated by that operation, I've got a complete model of that operation that I'm using to manage the bike through. So I'm managing the bike through the model. Okay. In terms of the management organization, because this is something I want to be able to come on to, the management organization is relatively simple. It's just me looking after the motorbike. So that's not too difficult. Let's move forward a few years. I used to be also a process control engineer. So I was building software to control laundries, to control process plant, to control boiler plant. But when I was at university, I was doing a research into adaptive systems. And I had a problem that was given to me working when I was doing some work for the health authority, was trying to improve the temperature control within an operating theatre. So this is something I thought about. And I came to the conclusion that I'm thinking I'm being given the wrong problem. It's interesting, you know, you should always be challenging maybe the problems that other individuals are giving you, because ultimately, why are we interested in temperature? Surely if I'm a surgeon in an operating theatre and I might be standing there for 8, 10 hours doing it, maybe a hip replacement operation, it's comfort that interests me. I want to remain comfortable through that period. So really, having a model of temperature is not really good enough. What we're looking for is a model of comfort. And a model of comfort has a number of interrelated parameters. We're looking at the humidity. We're looking at the dry bulb temperature. We're looking at the speed of the air. We're looking at the radiant temperature from the walls of the operating theatre. So the problem of controlling comfort is a lot more difficult than controlling temperature. But now what's interesting, I'm building models of something that really I couldn't really see. I was building a model of the motorbike, but this time I was building models that were related to more to do with thermodynamics than something sort of physical in the real world. So I'm slowly moving away from the physical world into a world that maybe I can't see, so I've got to imagine what this comfort model might look like and what would be the shape of that model. So again, I've got a model. I'm always asking questions through the model, so I can actually improve the variety of the model. If I can increase the variety of the model, it means I can absorb more questions from the environment. I can absorb a thermal perturbation coming through the wall of the operating theatre, because the model has been designed to be able to counteract an increase in temperature. Again, we've got medium variety, but again, I was designing this on my own or maybe with one or two of my colleagues. So organization itself wasn't the problem. Okay. The issue I've got now is that further on in my career, working for the health authority, I was responsible for the entire estate, the hospital, and at the same time, later on, just not far from that, I left the health authority and I started to work for British Telecom. And working for British Telecom, I was responsible for the public payphone service, where I was, had lots of managers working underneath me, and I had about 4,000 or 5,000 telephone points around the north of England that I was also responsible for. So now I've got a different problem. I've got a problem associated with modeling management. How do I go about modeling management? Up to now, I've been modeling a motorbike, something, incidentally, I could stand up and I could draw a model of the motorbike on a screen and everybody would recognize that as a motorbike. I could draw a fish or an elephant, any of these things in the material world, we would all recognize because we all see the same things. We might think about the things that we see differently, but we invariably see the same things. My challenge now is I'm trying to build a model of management, a model of the organization that somehow is different. And that's the journey I want to go through, is how do we actually build a model? What is it I'm actually modeling? So that's a very, very high variety situation, looking at organizations that comprises of many, many people. So I recognized that I was also part of the system I was trying to model. I was there as a manager, but there were lots of other managers around also managing the operation. So how could I model the I? How could I model me into the model of the motorbike? Or indeed, how do I model I into the model of the operation? Remember, the I really is the brain. And remember, the brain's also got a model, and it's got a very sophisticated model of the world around me. And there's no way I can model the brain inside, say, a neural network inside the computer. The computer deals only with syntax. We talk about semantics. There are no semantics. There's no meaning or understanding in a computer. That, at the moment, is considered to only reside in consciousness within the brain. So there's no way at all I can somehow take the consciousness of the brain and put it into the model. So I've got the challenges. How do I model the I? How do I model myself and maybe the hundreds of other individuals within the business? How do I model that in some form of model? So all of them, up until this point, all of my models had been about models of machine without including the I in me, the I in it. So let's continue this journey, trying to understand effectively what are the different types of models. So I want to talk briefly about model classification. We talked about the material world, and we talked really about the invisible world of the of comfort control inside an operating theater, and the invisible world which constitutes the organization. We can go into a business and we can see people moving around, but we don't understand how they're organized. It's very difficult for me to be able to observe people moving around and write down on a sheet of paper what the organization is that's controlling them. So that's really something invisible. And yet I'm trying to get control, right? I'm trying to get control. So we can look at simple systems. The physical systems can be considered physical systems. I've got a mouse that's on my desk at the moment. And if I want to move the mouse, I use force. I can't tell it to move. I can't persuade it to move. I just move it. It's simple. So this is really quite a simple type of model of that physical world. And that's what we call the physical stance. The next stance is the design stance. I could give you a watch, but I could remove the pointers and I could just give you all of the machinery inside the watch. And you might look at that and you might have difficulty understanding what the purpose of the watch is. So what we do is we take the design stance for complex machines. And what we do is we would instruct that machine to do something. Okay, we're not moving the cogs, we are telling the machine what we want to do. So what we'll do is we'll be sitting in the car, and I might instruct the car to move by a voice command, and it would move that. All right. But now, again, I'm moving into the area of organization, which is what I'm calling the biological world, with people coming together. People have got desires and beliefs. And the best we can do with this is understanding maybe the intentions of individuals that we are working with. Well, if we're all working within a business, we all have similar intentions. We're being rewarded to come to work to add value to the business. So we've got similar intentions. But again, even within the same business, we can't tell each other really what to do. We can persuade people that this is really what we should be doing on behalf of the business. So we can see we've got different really types of models: simple models, complicated models, and complex models. And we'll just have a look at ways of, I just wanted to make a case here for the model. Now, having gone through models, let's just try and really to summarize really where it is that we are here. So this is sort of the sake of summary. So reason is the thing without which our state would be the state of wild beasts, of children, of lunatics. It is the thing whereby we picture our intellectual acts before they become manifest. Remember the pneumatic vibrator that I was speaking about? Before that became manifest, I was able to picture my acts inside the model and make a prediction. So it is the thing whereby we picture our intellectual acts before they become manifest to our senses, so that we see them exactly as though we had sensed them. Then we picture these pictures in our sensual acts so that they correspond exactly with what we have represented and imagined. So let's conclude here that models without action are pointless. Action without models is dangerous. We're moving forward blindly. Actually, it's interesting. Action without models is dangerous. We could almost relate to a silo, which is a system that's not working strategically. It is a system that's working in isolation within a business, right? And we've got to somehow engage the silo with the direction that the business should be moving in. So models are not right or wrong, but need to be adequate for purpose. So reflecting on my experience, so I want to talk a little bit about a conference I went to a number of years ago in Orlando. And at this stage, I'm going to refer to my model of my presentation again. And what I've done is I've broken this model down into two sections. I'm calling the section that I've talked about the material world. I've touched on organizations, but I haven't gone inside the organization. I've called that pre-Staffordиan. And I've come up with that name because I've been working with a guy that'll come on to in a minute called Stafford Beer, hence the term Staffordиan. So I'll say a little bit about Stafford in a few moments. But we've got the two parts. We've got pre-Staffordиan and post-Staffordиan. So we could say that this is really like the sort of the world of mechanics, the material world, and this is the imaginary world that we all live in now. So let's go on. So yeah, about 20 or 30 years ago, I got invited to give a lunchtime talk at the Cybernetics conference in Orlando. So so the individuals that really have made a big difference to me that were present at that conference was Stafford Beer. So Stafford was a British theorist, a consultant and professor at the Manchester Business School, but he's been best known for his work in the field of operational research. Yeah, so I was invited to give a talk at the AI and Cybernetics conference in Orlando, Florida, and it was actually late in the evening when the after-dinner guest arrived to give a talk on cybernetics. And at the time, I had not come across Stafford at all, so I did not know of him. But during his talk, right, he said three words that made the hairs on the back of my hand, my neck stand up. These few words created a paradigm shift in my thinking, providing a new way of looking at, and more importantly, understanding organizations. Remember, this was the problem I had. I was building models of material things, but I was struggling to understand an organization. So the person given the talk was, there we are, there's Stafford Beer. Stafford, a cybernetician and a leading authority in organizational science. But the three words that made that shift in my thinking, that made that paradigm shift, they were taken from the work of Norbert Weiner. So Norbert Weiner defined cybernetics. And he said some words, it didn't really hit hard at home, but effectively, these are the key words that he said. He said, in the animal and the machine, right? So interestingly, Norbert Weiner was not making a distinction between the animal or the machine. And to me, the animal related to the biological world, to the biological continuum that we were talking about before, and related to organizations. There was no need to make a distinction between the machine or the organization. The machine was the organization. So this meant there was no need to make, from a cybernetic perspective, a distinction between the animal or the machine. Organizations were people animal-centric and could be viewed cybernetically from an information and regulatory perspective as machines, and thus models as machines. So the challenge was on really is, how could I restate the problem, reflecting on my earlier modeling days of motorbikes and industrial plant? So the key insight came when I recognized that a major part of the information and regulatory system I was acquiring the knowledge for was really being able to integrate that knowledge from different aspects of the system. I was coming up with a design for the system, but I was also part of that system now that I was trying to model. I could model the eye into the model of the motorbike. I could model the eye into the model of the system. Thinking more generally, of course, for larger organizations, I could model the eyes. I could model the eyes of many people into the model of the business. And we'll have a look at the work that Stafford have done. But I'll just briefly sort of say a wee bit more about Stafford Beer before we start looking at his model. So what is cybernetics? Cybernetics is the science of information and regulation in the animal and the machine, in the organization and the machine. And this is what I want to take forward. So in a way, again, having models, does a ship sail no better than a drifting log? To be in hell is to drift. To be in heaven is to steer. I went too far there. So effectively, we want to be able to build now models to make predictions about the future. We want to build an organizational model that will bring the different parts of our organization together. So the insight that Stafford had was using the human physiology of the actual brain. So he broke the brain down into three areas. So we had the sort of the neocortex, which is the area of rational thought. We've got the limbic system, and we've got the reptilian brain. So let's consider, I don't want to go into any detail. Remember, I want you to understand the power of models here, not necessarily the detail of what I'm talking about. So we can imagine that this is our monolithic organization, and this is the problem. A lot of businesses are managed as monoliths, right, where the control hierarchy is top down. So those organizations are very low, have a very low variety. They have a relatively small number of touch points into the environment and a small number of touch points into the organization themselves, right? It's just a tree structure unfolding. It's a very simple overall hierarchy. And what Stafford done, he developed what is called the viable systems model. Right. I don't really want to scare you when I show you this next diagram. Remember, the idea is not to understand the details of the diagram. You can do that offline later on if you want to be able to understand more about it. But the idea being this is the model that Stafford sort of created. I'll just briefly go through it, but remember, don't feel intimidated by the model. Remember, if you look at maybe researchers spend about 90% of their lifetime trying to understand each other. So I don't expect people, if they haven't seen this before, be able to grasp it. But the idea being is that this model has got a number of touch points. So what we've got is rather than having the conventional hierarchical model, here we've got a business, and you can see we've got a similar structure inside, but you can see the shape of this business inside this larger business, it's got the same shape. So it's fractal, and the whole structure is congruent, which enables me to drill down infinitum, but it means we've got many touch points going from the model into the environment, okay? And many touch points going from the higher echelons inside the organization to the lower levels of the organization. And I want to be able to demonstrate how I'm using this model of organization to bring the organization alive so we can see it. But the way that it was drawing here, the problem that I think Stafford had, it was incidentally, I got to know Stafford very well, and I worked with him for about 10 years in this area. So I really got to understand the technology, and he's written a number of different books. But the problem I think Stafford had with the way he had drawn this is that as you get into further and further detail, I'm just going to bring, sorry, my pen up here, my laser pointer. As you go further down here, right, it's very difficult to actually draw the same business, the structure of the model that we've got at the high level. At the lower level, it sort of disappears, right? So what I've done here is I've inverted this. I've drawn this inside out. And what I've come up with now is I think I've got to take that off. So what I've done is I've just inverted the model that Stafford is generated, so I can use this to be able to get a better visual representation of the actual business itself. So this is what I'm calling my fractal. This is a sort of a snowflake model of an organization, where this could be effectively this could be BT Group, the telecoms area in the UK. I'm just going to get me. So this could be BT Group round here, and these could be the different lines of businesses. This could be then another line of business within a line of business within a line of business. But at each level, we've got all of the main components of the actual model. So at the highest level, we've got what we call identity. Identity is what this unit is about. System 4, as he calls it, is about strategic planning. It's about planning for the future. And the innovations is really the new ideas that come from System 4 need to be able to impact upon System 3, otherwise the System 4 investment is not being realized. And that happens through innovations. So by being able to be better connected to the environment, and we can understand the changes that are going on in the environment, we can prepare ourselves for the future by being able to regulate, right, the innovation rate of this overall system. And this is really the organizational structure required to be able to manage all the different aspects of that business. And of course, innovation rate is important for us to be able to not just necessarily adapt to the future, but also creating that future. I'll just take this light pen off. So I want to just move on and now talk a wee bit about when we're using the model, how can we get the conversations occurring across the business? So we've got a model, we understand each other, but again, we're still working potentially within silos. So I'm going to talk a little bit about silos and what it means to be able to integrate information. So let me just sort of ask a question here. How well do the parts of the diodes know each other? So there we've got, these are photodiodes, maybe it's on a camera, right? And we know that these photodiodes create a picture. But remember, the picture doesn't really exist in the photodiodes. The picture is generated via the brain. So effectively, I could make a cut through the photodiode within reason, and the function of the camera wouldn't change at all, because effectively there is no direct connection between the photodiodes. These connections only occur within the brain. So if I cut the photodiodes, which is what we do, it's interesting. These are the sorts of things we do in a business all the time. We will make cuts across the organization, and business units are left in isolation to be able to work on their own without moving forward strategically. They might have their own plans, but those plans could be moving them in the wrong direction. What happens if we cut the brain? If we cut the axons across the brain, of course, that becomes disastrous. That becomes a big problem. You can imagine that when we've got the split brain syndrome, there's almost two individuals inside the head of that individual. So effectively, cutting the brain would destroy the quality of information that's generated by the connections between the neurons. So in a business, we need to be able to restore the conversations that take place between the different business units. And this is what I'm trying to show on this last sort of area on the right-hand side. Okay, we're showing the brains. I'm showing the brains here within inside the organization. But it's interesting, if you look at some of the connections between the brains, they do vary. We've got brains here that almost seem to talk to each other. So we've got a brain here that is talking to this brain here, and in turn, that brain will also talk back to that brain. And this is what we call a conversation. Okay, so conversations need to be both affective, and they also need to be effective, right? This brain is being affected by this brain, right? And as well as also affecting that brain. So this enables us to be able to build a bigger picture of the organization when we're developing strategies to be able to move forward. So we're developing a strategy by conversing together. This other brain is not connected at all. This brain could be considered a silo, and it will end up just doing its own thing. And we've got a brain here, incidentally, it has an input into these other brains, but there's no output from those other brains into this other brain, right? So I can almost classify that as being, this becomes the organization, this other brain would be the context. So these are the brains of our suppliers in the environment, and they provide the context for effectively how we're going to move that business forward into the future. And this other brain is just sitting there. This other brain may as well just be the environment. So here, out of that relatively simple diagram, we can actually identify three concepts. We've got the concept of the organization. We've got the concept of the context that we use to generate information. And then we've got the actual environment, the business, the context, and the environment. So we talked a little bit about conversation. So let's see what's going on when we're having a conversation, because this is so fundamental to amplifying variety in a business, trying to be able to increase the information that we have in order to make better decisions. So effectively, I'm showing just the two brains here. We've got two brains. And what we're doing is when we're conversing, initially we start off with a shared white space. The area of overlap of these mental models, really, the overlap represents the knowledge which is common to both brains, okay? And what we do is that when we converse, of course, what we want to be able to do in the business is to be able to increase the area of that shared white space. So I'm showing effectively, this is just randomness. So if we're sitting in isolation without talking, effectively it's like what we call asexual reproduction. We've only got access to our own meme pool. The meme pool is very, very small. Through a conversation, that conversation gives us access to a larger meme pool. And then what that means is that we can start sharing the ideas. And the white space in the middle is really the ideas that we agree upon. If we're trying to determine the strategic direction of BT's switching network or the telecoms network, what we do is we bring the different brains together who are responsible for the different parts of that network. We could be bringing together switching brains and transmission brains, and understand by working together how we can come up with a more effective plan. Because of course now the context has changed. If we're working now with silos, we're working within the transmission silos of transmission technology silos and the switching technology silos. But when we bring the two silos together, effectively what we've got then is the network. The network are these two silos coming together to produce the network. So what we want is we want solutions for the network. And even with a simple diagram like that, we can really start to identify some of the key maybe metrics around how effective an organization is. So here we can say that the area of that shared space here is the current amount of knowledge we've got about the network. This is the shared knowledge of the network. But the rate at which that shape can increase, or the rate at which that knowledge increases with time, we can call intelligence. So intelligence, I, equals the rate at which we're acquiring knowledge. So the challenge we've got is to come up really with techniques that will enable us to be able to improve the way that we increase the knowledge of that aspect of the business so we can develop more effective strategies. And again, we talked about scaffolding earlier on. So I'm just giving an example really of the scaffolding. There's the complex scaffolding that represents the network. And as we ask questions through the model, what we do is we can increase the complexity of that model that really represents the additional knowledge that we are acquiring through these interactions. So this is very important within businesses. We need to talk a lot more, but to be able to talk together, we need these discussions to be mediated via the model. The model will enable us to be able to ask questions and have those questions answered. And of course, the model itself can be underpinned with using IT to be able to, if I'm asking a question, it could be that the question needs to be asked by a model of the actual operation. I may be trying to understand the impact of a fault on a port of a line card of a transmission system. And I want to understand what those patterns are. So in a way, part of the organization is bringing the brains together of the individuals as well as the sort of the knowledge of the actual business itself, bringing all of these things together. So coming down, we've talked about the viable systems model, a model of organization. We've talked about silos and how bad silos are working in isolation. And by integrating the coming together of the silos, we can increase the quality of the information. And again, we can amplify that information by having good quality conversations. But remember, a conversation is both effective and effective. So let's just briefly go back. So A is affecting B, and B is also affecting A. And that is so important because what we can then do is to increase that common knowledge, that common area of understanding, and use that for improving the quality of decision making within the organization. So in a way, this is my sort of Rosetta Stone. So remember, what we were trying to do here is to get a good understanding of the power of models and networks, the coming together of people coming together through conversations in improving decisioning effectiveness. So the power of the model and the power of the conversations within your network will enable you to answer the most rudimentary of questions that a business is asking itself on a minute-by-minute basis. That faced with this predicament, what is it that we should be doing next? I'm just going to now, for the next 4 or 5 minutes, just finish off with a case study to show how I'm using this technology to be able to make a real difference within a business. And I'm just going to come back to the an area I discussed earlier on, really, which is the payphones. So out of what we've discussed there, we can move that into maybe an overall framework where I can try and understand what is the maturity of a given organization. How mature is your organization? You know, so I know, how is organizational maturity measured? So effectively, we've got 3 areas of that of the business that we need to understand. One is to do with the capacity. Are there adequate resources for that individual business unit to perform this function? Connectivity. Does this function have the relationships? Connectivity in terms of conversations and data transfer with other parties that's needed for that business unit to perform adequately. Balance. Can both parties resolve their issues and achieve the outcome? So the balance will come from that conversation and getting an agreement over a shared understanding. Remember, the context is different now. We've got 2 people coming together, bringing their own context together. That increases the umbrella that's over them, the umbrella representing the overall context. So can both parties resolve their issues and achieve the outcomes they need through their relationships? And finally, what is the overall amount of information that we're generating through having that connectivity and balance? And we can have a measure of overall consciousness here. So the underlying model, so we're talking about, the organization, but the underlying model that I was using to cohere the payphone organization was quite simple, really. It was based on understanding what serviceability was. So serviceability was about understanding the fault rate, the time it took to be able to repair a fault when it occurred. I didn't mean to go back there. Just bear with me. Yeah, so it was the time taken to repair the fault as well as the time taken to detect the fault. And this formed the basis of really the organization. That was what, and it's interesting, the organization effectively was the computation of this equation. Let me just go on to that. So the organization itself was the computation of the equation. So when I was given payphones, the organization itself appeared to be quite fuzzy to me. I wanted to try and make sense of it. Having gone through the work of Stafford, understanding what serviceability was, I was able to bring these models together. So I had the model of organization, and within that, I had the model of serviceability. Now, I took over payphones during a very difficult time within our district. I worked for the North East of England district, and our payphone serviceability was running at about 57%, and we were bottom of the league table. There was 30 districts throughout the UK, and we were bottom. We were 30th in the league, okay? And I had literally about 5-6 months to try to improve the quality of the service. So by being able to bring all of these ideas into play and start managing really a business now through a model. Remember, I was building mechanistic models. I'm now running this business, an organization comprising of brains, comprising of people, really through a mathematical model and running that recursively through the fractal structure. So I was able to unfold that model in a fractal way, maximizing information. So this is phi, the Greek word phi, meaning information. I'm trying to maximize the amount of information to be able to look after that payphone organization. And during that period, we were able to get a performance at the end of that of up to 98.7%. So we came top of the league within a space of 6 months. Applying this sort of technology, we made quite a significant improvement. So what I'll do now is I want to be able to close the formal part of the presentation and open the session now for questions and answers. While I'm waiting for any questions to come in, on the assumption there may be some questions, I'm just going to briefly, yes. Yes, so I've just got a question that's come in here. The work that you did on the public payphone service sounded interesting. Can you tell us a little more about how you use cybernetics to be able to model the service? Yeah, certainly that's a very, very good question. So I'm just going to briefly go back to the case study here. And the real challenge that we had with building a Cybernet model of a payphone organization was to try to unfold that overall equation. So I'm just going to put the pen on here for a second. What we can do is we can draw around here. So I'm just going to put a pen on here. So the idea is that this was the entire payphone organization. Okay, we had the serviceability equation that was applicable all over. Remember, this is a fractal model. So serviceability appeared in each of these different business units. These business units would represent the different geographical areas of the country. So this would represent one geography, this would represent another geography. But the models are still applicable. The model, the serviceability model, is still applicable to each of these different geographies. So what we can do is we can then unfold that geography down into the different specialisms. So there was a specialism that was going to be focused on the fault rate of the actual payphone itself. So one person would specialize on reducing the fault rate. There would be another area, another specialism to do with being able to detect when a payphone would go faulty. So that individual, that business unit needed to make sure that if a payphone did go faulty, we knew about it as quickly as possible. And the other area was the time taken to be able to repair the fault. So it's making sure that we've got sufficient resources out in the in the geographical area to repair the fault when the fault when the fault occurred. So one was about reducing the fault rate. The other area was about detecting the fault when it occurred. And the other business function was about repairing that fault as soon as we could. And we would have something like a 2-hour target for repairing the fault. The detection time would need to be less than 10 hours to be able to repair, to detect that the payphone had gone faulty. And of course, we had the fault rate itself that needed to be around about 15 faults per year for the actual payphone itself. And if we put all of these into the payphone serviceability model, we would come out really with a figure of serviceability. What was interesting is that when we started this, the serviceability was pretty low, and this was our target. And because I was using this as a model, and I knew the rate of improvement of detection, the rate of improvement of being able to reduce fault rates, I would be able to see what that rate of improvement was, and being able to then say at a certain time what I would expect to get. So again, that is the power of the model. I had a model that made a prediction. This was our prediction, and I could then check to see whether we were actually on target. And I felt very comfortable that we would actually meet that 95% target that the general manager gave us. Right, thank you for that question. Right, let's get out my pen again. Right, maybe we've still got a few minutes. What I will do is I'm just going to have a look at this final case study. And this is the sort of the area I was responsible for before leaving BT. And this was about really the decommissioning of the telecoms network. This is an example of where we've got to have a model. This is the sort of the inside of an exchange. And of course, all these wires and boxes look the same. They have different functions. So I've got 3 functions within this area. I don't want to get down to the technicalities, but just to show you the overall process. So what we've got there is we've got a model of one technology, a model of another technology. Again, everything is model, and a model of the PSTN. Now, we could manage these technologies in isolation, but that really isn't a very clever thing to do. My challenge was to be able to integrate these different dimensions together to come up really with a model of the network, as I've said on a number of occasions. So I've got to link these together. So by using that in a number of different techniques, we developed two AI applications that would enable us to be able to solve that problem. So what I'm doing here is I'm showing really the faults coming in. These are the individual areas working in isolation. So if the card went faulty, we would repair it. We could provide a service, we could compact the service. But by bringing all of these individual areas together into an integrated model of the network, the problem was compounded, of course, because it's very difficult to optimize a very complex network problem. So we developed 2 tools. One tool was called Kaplunk, right? I don't know if you've heard of the game of Kaplunk, but you can imagine that we've got a cylinder with lots of straws going through the cylinder. These are the straws here, holding up the resources that we want to decommission. And these are sort of viewed as models inside the game of Kaplunk. So as you withdraw a straw, you'll get maybe the odd marble falling to the bottom. So the optimization problem was what were the minimum number of straws? Because remember, to be able to remove an individual straw is very, very costly. What is the minimum number of straws that we can withdraw from the cylinder that we can withdraw across BT's UK network in order to maximize the removal of the resources. So that was one area that we're using AI in conjunction with the model of organization and the model of the actual network itself. That was to do, incidentally, that was to do with transmission systems. But as far as the switching systems is concerned, we developed another algorithm called the waterfall. Again, this is an example of using models. It's using models within models of organization to get the right context and so on, to bring all of that together. So we use the waterfall as the compaction algorithm. So as I'm reducing the demand on a resource, I've got to then, it could be that I'm left with 4 or 5 disparate resources where I can compact to reduce the overall power consumption. So bringing all of this together, this is another example of where I'm bringing the model together in terms of a model of the organization. We talked about the viable systems model. We've got the system 5, we've got strategic planning, we've got operating planning, and we've got the different individual business functions here. So by bringing all of that together, what we'll be able to demonstrate that we were able to reduce the actual commissioning costs of the network from the base case of continuing to do nothing to one of compaction and decommissioning. We could effectively save about £500 million over the life of that overall asset. So what I want to do now is to be able to close. So if you would like to follow up on anything that was discussed about what I've said today, then please visit the eptic.org website to get in touch. Okay, thank you very much.